Okay, we are live on our Hangout on Air for August 5th, and our guest speaker today is Mr. Wofford. Mr. Wofford is, he's codes for a living, and I have to plug this, Mr. Wofford. You created the app that's available in the App Store, the
That's
Mac
right.
App Store. It's called Doug. It's D-O-U-G and D-U-G, right?
Right, that's it. iOS App Store for
It's
iPhone.
iOS, an iOS app. I have actually played this app quite a bit,
Huh.
and and I got hooked on to it because it was, I just wanted to see how far down I could get
Yeah,
and everything. So it's quite a fun app, and I think that that's something that would be worthwhile for others to download as well.
good. Thank you.
We're going to hand it off to you, Mr. Wofford, because we know you have a presentation. You came into one of our elementary schools here in Midlothian, and we certainly enjoyed and learned so much from you. And so we asked you again here today so that you can share along that same information, and you also have a couple of other tidbits for us about coding.
Absolutely. Well, thanks very much.
Sure.
Yes, Mrs. Green from J.R. Irvin asked me to come in and talk about programming to her students. She was preparing to teach them about coding, and she went on after my presentation and used the code.org website, which I really think is a awesome website for learning programming from young ages to, I think they were second graders, all the way up to adults would enjoy the code.org. So it's a good resource. But I introduced the students to programming with my own experience. And I'm going to go through the presentation that I gave to Mrs. Green, although I've changed it a little bit for a teacher audience. But I hope that it's food for thought for how you might think about programming and how it might help your students and how you might teach it. So I'm going to switch over here with screen sharing, and I'll show my screen here. Okay, so is that working? Do you see my screen?
I sure can.
Great, and I'll start this presentation. Can you still see that?
We see you.
Well, let me try the screen sharing again. Just a second. Let's see here. I'm going to try it this way. What about that?
Maybe give it a second here. We saw it there for a second, but it disappeared, and then you came.
When it comes up, it'll say, "What is programming?" That's the top
Okay.
of the presentation. Well,
Had like a black theme.
yeah, sort of a black background.
Uh-huh.
How odd. Let me try it again.
Well, same here with my camera. I don't know.
Yeah. No, that's not it. Screen sharing, screen. Share. I guess that's the whole screen. And then if I go here.
Okay, that's good.
See it now?
Yes, sir.
What is programming? Okay. So there we are. What is programming? What is it to program a computer? What does that actually mean? Well, it's a question of how do you control this amazing device that people have developed in the last 50 to 100 years called a computer. How do you make video games? We'll talk about that. And how do you make a computer do whatever kind of new thing, whether it's a new video game or something else? I am Jeff Wofford, as you've heard a couple of times. I have a couple of girls in school. Kat is still at J.R. Irvin. She's actually going into 4th grade here. And Ellie Wofford will be going into 6th grade at Frank Steele this coming year. And I am a programmer by trade. I do mainly games, but I do other kinds of programming as well. So, when I talk to the students about this, I ask them about their experience of computers. What computers do they know of? And they usually talk about the computers in the computer lab or the computers that their parents use at home. What do we use computers for? And, parents use them for emails or maybe for doing a budget. The kids use them to write papers, write essays, or to look up things online, have stories read to them. So what is a computer fundamentally? What is it really? And I remind them, and actually, you know, your iPhone is a computer. Your pocket watch is a computer, if people still have pocket watches. There's computers everywhere. The thermostat in your house is a computer with a microchip and all the other features of a computer. So really, computers are everywhere. Your cars have computers in them. So a computer is actually not just a thing with a screen. It's actually any sort of computing device that does calculations, plus, minus, multiply, divide, that kind of thing. It takes input. That's important for a computer. It has to have input. And it thinks about that input. It processes it. It changes it. It calculates on it. And then it spits out output. Input, processing, and output. A computer is a device that does those three things: input, processing, and output. And they do them for cars, they do them for air conditioning systems, they do them for all sorts, but of course what we like best is when they do them for games. So in an Xbox you have an input device, which is your game pad, and then you have your processor, which does all the thinking about how the game should work and how the objects should move and what the score should be. And then you have your output, which is your video, but also your speakers, the ways that you see what the computer has to show you. Now I should stop. Are you guys still with me? Any thoughts or questions so far? Barbara? I hope you're with me.
Sorry, she's muted and she can't get herself unmuted, but I can't see your PowerPoint. I saw it come up and then it went away.
Oh.
But I'm taking notes.
I see it now.
You do see it now?
I don't.
It's going in and, oh, really?
No, I see you.
I see you.
Give me now. Okay, let me try this again. I just want to make sure you get as much of this as you can. Of course, I can send the PowerPoint over as well.
Okay.
Oh, that'd be awesome.
Yeah, you can bring the audio and the PowerPoint together later on if that helps. Let's see. So there, can you see that?
Yes.
What is a computer? And then I'm going to try to go to full screen mode because it does the animation. See.
Still good.
Still good?
Nope, now it's you.
Wow.
Google Hangouts is. I actually use Google Hangouts a lot in my work, and it does tend to have some foibles. Let me try it this way, actually.
Like not being able to unmute yourself?
Yeah. You know, computers are hard to program. And
You know best.
some parts are harder to program than others.
Yes.
I would ask you for some tech help, but...
Yeah. Okay. Well, I'm going to try it this way. This doesn't give all the animations and everything, but I think it'll be a little more reliable.
That's good. We can see it.
Do that. Okay. Yeah. Okay. So, so one of the things that I do in the class to teach students about computers is I act like a computer. I act like a robot, and I pick one of the students as a volunteer, and I tell the students that I'm a robot and I have certain commands that I will obey. I'll turn right, I'll turn left, I'll take a step, I'll raise my arm, I'll lower my arm, I'll open my hand, and I'll close my hand. And then I challenge the student to get me to go over and pick up something, pick up a cup or a book or whatever. And the student then has to think very carefully about exactly how to get me to do that. There are a lot of things you take for granted. When I did this with Mrs. Green's class, for example, the student forgot to raise my arm. So when I went over to the desk, my arm just ended up below the desk, and I couldn't pick anything up. So you have to raise the arm before I get to the desk so that it's at the right place to pick up the cup or whatever. So this gets the students aware of something, which is that a computer does just exactly what you tell it to do. And I also ask them to think about how I'm like a computer. I have input. I can hear the commands with my ears. My ears are my input mechanism. I have output, which is really the muscles in my arm and my legs. I'm able to move myself around. That's my output. And then my processing is my brain, I suppose, or whatever it is that allows me to go from the commands that I hear to the movements that they want me to perform. So I act like a robot, and the students start to understand these ideas of input and output and processing. A computer is, this is just repetition really, a computer is a machine that has input and then processing and then output. And a program is like when the student is telling me to move around. A program is just a series of instructions that we give to the program as input. So you can see an example of that there. Yeah, hopefully you'll be able to read that. It says turn left, step forward, turn right, step forward, raise arm, open hand, step forward. That's the sort of thing you might tell a person or a robot to get them to move around. We call that sort of language code. You can see that in this example, it kind of is sort of readable. Turn left kind of makes sense, but it doesn't look like English. The parentheses are strange. That semicolon at the end of each sentence is strange. But those extra parts are what make it so the computer can understand the language clearly.
Mr. Wofford.
Yes.
Real quick question. I have always, let me turn me down. I've always wondered, can you hear me all right?
Yes.
Can you hear me?
Yes.
Okay, good. I wanted to know the parentheses and the semicolons. You know, the spaces matter, the semicolon and the parentheses matter. Without them, the code wouldn't work. And you said that that's how the computer knows to read that.
Yes.
Is that a little over, I mean, explaining why those are there?
Well, let me make sure I understand your question. Do you want me to go into more detail of why they're there, or do you think?
Well, I've always just been curious about the parentheses and the semicolon.
Right.
And why they're there.
Oh, and why they're there. Yes. Okay. Yeah. A lot of there are a lot of different computer languages, just like there's a lot of human languages, and the computer languages have different what we call syntax, different rules for how they're supposed to be written. But this is pretty typical, where you have the semicolon at the end and the parentheses. The general answer is this: computers are actually really dumb, and they can't read between the lines of anything you say. So a famous example of this is in computer science circles is if you tell a person time flies like an arrow. Just think of that sentence: time flies like an arrow. Well, a person knows probably that you're talking about time and the experience of time, and that time feels like it moves straight and fast and unavoidable. A human being can sort of see that from those words. But a computer cannot understand that at all. And so if you tell a computer time flies like an arrow, if it understands anything at all, it might think that you're telling it that it should time some flies, like they're at the races.
Mm-hmm.
Time flies, and the way that you time them is you time them the same way that you would time an arrow. So a computer cannot you see how it gets it wrong there? It can't. It cannot fill in the gaps that human beings fill in the gaps all the time. So the semicolon tells the computer this line is done. We're finished, and now there's going to be a new statement coming up. And the parentheses tell the computer the word that it's just seen, in this case turn left is the first one. The parentheses say this is a function. And there's nothing in them because the function takes no arguments. This makes more sense than you might think. If you remember from like maybe 8th grade math, that if you have a function f of x, f of x equals y, or f of x equals y squared, or whatever. We all did a bunch of that.
Right.
In school. You can actually have functions that take no variable. So it wouldn't be f of x, it would just be f of nothing. But if you picture that in your mind, it would be f parentheses x, close parentheses. But if there's no variable, it would just be f open parentheses, close parentheses. Does that make sense?
Yeah, that makes sense.
And that's what turn left, open parentheses, close parentheses means. It means turn left is a
Fill in
function
the blank.
that there's no, it doesn't take any variables.
Okay.
Yeah. Okay.
The computer has to have it all like exactly right, or it can't understand it. If you leave off the parentheses, it won't know. It will have no idea what you're talking about.
Very cool. Thank you for explaining that.
Sure.
Okay.
So a program is like a recipe, and we might ask the students, you know, how do they make macaroni and cheese? Because a lot of kids have made macaroni and cheese, and they know that you have to, you know, you boil up the noodles and then you put on the cheese powder and stuff. It's really bad for you. And you put in some milk and you put on some butter. I recommend putting the butter on first, actually, because that way it melts better. Anyway, you have very specific instructions. And so we know that a recipe tells a cook how to put together a meal, how to cook something. Likewise, a program tells a computer how to do something. Programs have to be very, very simple because computers don't understand anything. They only do exactly what you tell them. You have to tell the computer what to do one step at a time, which is kind of like a recipe. The computer cannot guess. It cannot fill in the blanks. You have to tell it exactly what to do. So it's like a recipe written for a chef who is an absolute literalist. He does exactly what's written on the page, nothing less, nothing more. That is what a program is. It's code that tells the computer what to do, something like the recipe or a cook. So that's what a program is. That's what a computer is. That's what a program is. So what is a programmer? A programmer is somebody who writes programs. We know a computer language. Often we know several computer languages for different purposes. But most importantly, a programmer is somebody who has learned how to think like a computer so that you can communicate with a computer. And I have various examples here that I like to show the students of famous programmers. Ada Lovelace, the first programmer, was an English noble lady who wrote code for Charles Babbage's machine way back in, I think it was maybe the 1840s. I'll have to look that up, but it was very early. And there's in fact a programming language named after her. The programming language is called Ada, and it's.
I don't think I knew that.
Yeah.
We have her in the computer lab.
Yeah.
Ah. And then of course Bill Gates. I don't know if the little kids know Bill Gates, but a lot of people know him, and he was a programmer at Microsoft before he became kind of the boss. John Carmack is a famous programmer in game development. He lives around here. They work up in Mesquite, Texas, and he has written a lot of famous games such as Doom and Quake and what else? Rage is another one that he wrote. Marissa Mayer, let's see, I think she's now the CEO of Yahoo, and previously she was high up in Hewlett-Packard. And she was a programmer before she became kind of a big executive in these companies. And then John H. Thompson wrote the language Logo, which is a language that kids often learn programming with. It was more popular, frankly, like in the 80s and 90s. It's not used as much, but it's a nice little language for learning to program. And he's won lots of awards for computer science as well as creating that language. There's all sorts of people in programming. Anybody can learn to be a programmer, and I think more people should learn to be programmers.
On top of that, Mr. Wofford,
Yes.
I like to see that there are female role models, because I just think that that's something that a lot of our little girls don't think about. Especially, you know, my kiddos, I've told them about code.org, and I just want to get them started, and it's just nice to be able to show them some leaders that have already kind of helped lead the way, you know?
Yeah, absolutely. Very true. I mean, both of my daughters have done some programming with me. I want them to learn to program. Whether they do it professionally or not is up to them, but it's certainly somebody anybody can do, and it can help you with all kinds of jobs. And we need more girls in programming, more women in programming, because it's traditionally been difficult to get women to go down that path. I guess there's a stereotype against it or something, and yet many of the great programmers have been and can continue to be women. So yeah.
And you're, I don't know, I think that it leads the way to other avenues, you know, creativity and really thinking through things. And you might even cover that here in your presentation, but that's something that we talk about also after we've done code.org with the students, is really try to talk about, let's not just think about it as coding. What are other things that we're learning as well?
Yeah, that's so true. I mean, why do we teach kids mathematics, especially up above the level of, you know, let's say you get to geometry and you're learning theorems. Well, kids are not going to be doing theorems as such when they're out, you know, selling cupcakes at the bakery that they run, or fixing cars, or even doing accounting. Geometric theorems are kind of a different thing from what most people do their jobs as. But we teach them theorems because we're really teaching them how to think and how to argue in the proper sense of the term, logical argument, how to discover things and discover ideas. And so it's a thinking skill. And programming is the same kind of deal. It's valuable in its own right, but it's valuable for everybody because anybody who spends any time doing programming learns to think better. It's logical, step-by-step, careful thinking, and that's healthy for the brain. It's healthy for people.
Definitely.
Yeah. Okay. So programmers write programmers that can help you do your homework. I have a program, for example, on my computer called Mathematica that is a math student's dream because it'll solve just about any equation in a tenth of a second.
That's funny. I was just saying that yesterday to a math teacher. We were talking about rolling out the iPads, and some of the math teachers just, you know, were curious. The way they've traditionally taught math, putting an iPad in their classroom is going to stretch the way that they're have taught it in the past because of a lot of the drilling the skill. But I did tell them, I said, you know, the kids can go home and they can put in these problems and, you know, outcomes and answers. So what are other avenues that we can take to get them to start thinking about this math other than just the drilling, which is also important, but just kind of getting them to think along those lines.
Yeah, that's very true. Yeah, that's a difficult one. Yeah, math education is really being shaped by the computer. Because a computer, after all, is a computer. And
right.
Our math education has traditionally been making people into computers.
Yeah. Yes.
Great value. Yeah. But you want a marriage between, I think working with computers all the time, I've discovered that you want a marriage between the human as a computer. Because you do want to do the drills, and you do want people to be able to do, you know, 4 times.
Got to practice.
You want them to be able to do it themselves.
Yeah, to be able to do it themselves. But at the same time, you want them to be able to use the computer to amplify their thinking so that they can work even higher. Anyway, thankfully that's not my that's not my challenge, but I applaud the mathematics teachers that are working on that.
I do too.
They control your air conditioner. They control the airplane and help it to stay up in the air. Modern airplanes actually cannot be flown by just a human being. If the computer goes down, the plane goes down. It's called fly-by-wire. The computer has to be functioning for the airplane to steer properly.
That's scary.
Yeah, it is scary, isn't it? Fortunately, airplanes have a great safety record despite recent events, so it seems to work. And they help us pay our taxes, and of course they help us play games. So programmers make all kinds of things with computers. At this point, I like to show the students, and I'll show y'all, a game that I have written. When I showed Mrs. Green's class this game, it was actually still in development.
I remember talking about what you were going to name it.
That's right.
Possibilities, and I thought that was fun. I went home and said, we were talking to a programmer about his app, and he doesn't have a name for it, and the kids were talking about particular names he might want to add, and I just thought that was pretty neat that you were asking them for their input.
Yeah, that's right. It was neat to have their feedback. And this is Doug. And I wrote all the code for this game, all the math that tells the little guy how to move around, all the physics for how the blocks should move around.
Now, are you showing us? Because we see your slide, just FYI.
Oh, okay. Yeah, no, I am trying to show you. Let me change the Hangout here. Let's see. Here's, well, I'll do this way. Okay. Do you see it now?
We do.
Yes.
Okay, there he is. Sorry about that. Yeah, there he is. He's moving around. So everything that happens here, everything is code. It's things like turn left, turn right, move forward, all that kind of stuff. But of course, much more complicated. You see that spider's about to get me. I better get away.
Careful for the avalanche.
Yeah, it'll fall on me if I'm not careful. So this game took me about 2 months to program using C++, the language C++. And the code for the game looks something like this. So
Wow.
here's the code for the player. You can see it's just lines after lines after lines.
That's daunting.
This is the code that, okay, when the player dies, can you see where it says player die right there? You still have that on your screen?
Yes, sir.
Okay. When the player dies, if you get killed by something, the game tells you what happened. So it'll say Doug died, or got squished, or sticky, or gooey, or pancaked, or squishy, or butternut squashed, or flattened. If you got eaten, it'll say eaten or lunch. And if you just landed too hard, it'll say one of these things. So you can see how the computer picks one of these sentences and then shows it to the player. It shows a proclamation. Show proclamation on death, and it picks one of these up here, and it becomes the death proclamation. And that's how it tells the player what happened when you die. There's code
His
like
death is determined.
yeah, it's been yep. The game knows how you died, and so it's going to tell you what happened. So that there's just tons and tons of code telling the computer how to do all the different little parts of the game. Just thousands and thousands of lines. So that's Doug.
That's amazing.
You can
And then-
download it.
Yeah.
The last thing that I do with the students, and I'll show you this, I think we still have time, is I just make a little bitty program. I use a computer language called Ruby, not because I think it's the one language that everybody needs to use, but just it's a handy little language. I'm just going to make a little program here while you watch that asks for the player's name or the user's name and says hi to them. So to do that, I'll use a text editor here. Can you see this?
Mm-hmm.
Okay. And I put in a little magic here that you can not worry about too much. This tells the computer that I want to use Ruby as the language. I'm going to save this file someplace. To a file called test.rb, which is short for Ruby. And then, just to make sure that it's all working, programmers like to do this. They like to say, puts hello world. I'm running a hello world program. And over here in my programmer terminal, I need to make sure that this runs first. And I'll run it. And it'll say hello world back to me. See there, this code made that happen. But now I want to make it so that it asks for my name, it gets my name, and it says hi back to me. But first it needs to ask for my name. So it says, what is your name? And then it needs to get the my name. It needs to get my name back from the input. So, I need to remember how to do this. Let's see. Oh my goodness, I'm forgetting Ruby to do this. I've been working in so many different languages lately that
Yeah.
I think it's standard.io.get. Oh no, it's just gets, I think. Gets name. And let me just make sure that's working here. If I get too committed to this. Name, what is your name? shoot, I'm sorry, guys. Normally I do it
No worries.
when I do a presentation like this. I sort of make sure I know what I'm doing.
Well, it's interesting.
Oh,
We're
yeah.
just taking it all in.
Yeah, name equals that, and then gets name. I'm gonna have to look at. I'm gonna have to remind myself how
You know,
I
I
do.
saw the first one. I know I was explaining a little bit about what you do and put in the program about asking the students input about what you wanted they wanted the computer to say and whatnot. It was pretty interesting, though. It's a
That's
great
right.
illustration.
The thing I'm forgetting is I can't remember how you get back from the computer what the name is. And like I say, I use so many different languages that this particular part has eluded me. Gets name. Huh.
You have an app to prove you've written a ton of code.
I don't remember where else I have it. I'm gonna look for other
Getting farther than I would have got.
Yeah. Projects is Mac. Name. I'm looking for other Ruby projects. If I can't figure it out, I'll move on, but let's see if I can find it. There's a lot of Ruby in here, but none of it's mine. Projects. Okay, here we go. Yeah, I don't see one that's going to help me really. Huh. Shoot. Well, I don't know. I suppose it's not worth me spending more time on it. I'll send you a program that that has it. It's one little keyword that I have to know.
Sure.
If I don't know it, I can't move on, and I don't remember it. So, oh well.
Well, like you said, it needed to be very simplistic.
Yeah. Yep. It has to be exactly the right thing, or the computer doesn't know what I'm doing. So, and I can't remember exactly the right thing.
That's all right.
It's okay.
Anyway, there it is. Programming is writing code that tells computers how to do new things, and that is my presentation. That's what I gave to the.
That was awesome.
Yeah, so explain just a little bit about, Ruby. When I was trying to remember, just to kind of give people a verbal illustration of what you did, it was you told Ruby to ask the name, and then you would say the name, and then, but you could make a change to that, right? You asked the kiddos, hey, what else could I ask?
That's right. When I first told him this, I did what I said there. So it would ask them their name, you type in your name, and then it'll say hello, Alice, or whoever put in their name. And then they had an idea for another change when we did this with Mrs. Green. I think I might have gotten it where it spoke out loud. Did I do that?
Yes.
It would say it, or you could hear it.
Yeah, that's what I was remembering.
Yeah, it did that, and then also, it also made it so that it would ask you how you were doing, and if you were doing. I think, isn't this right?
That's right, and you could say, you could write it based on what they said would be a different output, or what they typed. I couldn't remember though. That's what I couldn't remember.
They said something. If it said something like "doing fine," it would say "that's good," and if they said "not so well" or some other thing like that, it would say "oh, I'm sorry." So a little bit of a conversation.
But it was neat how you could write the code to give it a parameter rather than something distinct.
Right, you could make a choice based on what they did, if statements.
Yeah.
That's right.
Which I've learned a little bit through code.org and Code Academy. There was a little bit of that. I mean, a lot of that goes over my head, but it's still very, very interesting because especially having to think about every single step, which is why I'm amazed, I'm blown away that coders can do what they do, and creating games and whole programs, things like that. It's amazing.
It certainly is something that takes practice. It's not hard for anybody to get started with programming, and that's why code.org and Code Academy are so great. But yeah, to do it professionally, you usually have to go to college. Few people just teach themselves and are able to make a career of it without finishing college. I've met a few of those people, but most people have to get a degree, and it takes a lot of practice.
I can't imagine.
You end up having to memorize lots of little things, and more than I can keep in my head all the time. I have to look things up.
I'm sorry. When I cut you off, there's a lag, and I apologize if I do.
No problem.
But I was amazed to hear Dennis King, who's our webmaster, and he's just rolled out an updated look of our web page to make it more mobile friendly. But he said that he learned a lot of that stuff on his own, and I was blown away because I thought for sure that was what he got his degree in.
Yeah, it is possible. I mean, people kind of get obsessed with it, and you can end up teaching yourself.
It's cool stuff.
Did you have a question, Melody?
No, I was surprised that was not what Dennis went to school for too.
Right. I think it was like broadcast journalism or something that he got his degree in, and then he has a creative edge and ran with it.
That's cool.
That's funny.
I know you talked to Irving. Would you come talk to other schools, or are you kind of passionate about Irving since that's where your girls are?
Well, no, I'd be happy to come and talk to other schools. Along with my, I don't suppose we said this, but along with my programming work, I have also spent most of the last 10 years as an adjunct professor at SMU teaching computer science.
Oh.
I did not know that.
So I've done a fair amount of teaching of programming. And so I'm quite comfortable talking to groups, and I'm passionate about, I want kids to learn to program. So I'd be happy to go to other schools. Obviously we have to find the time to do it, but we can do that.
Well, you do a very good job, I think, explaining and simplifying it, not only for the adults in the room who really need you to kind of make sure it's in layman's terms enough that we understand it, but the kids, when you were done with your presentation in the classroom, a hangout is one thing, but to be in the room with them and seeing their eyes wide open, and at the end you said, who wants to be a programmer, something like that, and they're like, I do, and we've asked that a couple of different times, and I think it's just one of those things where they don't realize that's an option for them.
Right.
And so we're making it an option by having you come in, and we certainly appreciate you doing that for us and for the kids.
Great. Yeah. Well, thank you. I'm happy to do it.
Yeah.
Let me know if any teacher needs me to come in sometime, and I'll do my best.
I think you'll be hearing from Mrs.
Awesome.
Kern.
Thank you. Possibly.
Let me know.
Well, Mr. Wofford, we're going to go ahead and call this hangout. We appreciate your presentation, and you said you might send something for the program. What was it called again? I forgot.
Ruby.
Yeah, I'll send 2 files to you, Barbara. I'll send the keynote presentation. It's a Mac keynote presentation, because I think you'll miss some of it or whatever. But you can look at it again, use it. And then I'll also send the proper Ruby program that works and does what we were talking about. I'll find the one that I did for Mrs. Green, or I'll get you that.
Awesome. Now, tell us again the name of your app that everybody should download.
Everybody should download Doug, D-O-U-G, Doug.
That's right. I'll recommend it too, because I've played it and love it.
Yeah, thank you.
Well, we're going to sign out from here, and again, we thank you, Mr. Wofford, and wish you well, and hope to see you again soon this year.
All right, thank you. Thanks very much. Have a good day.
Thank you.
Thank you.
Bye.
Bye-bye.